3D printers are really neat, and they're really good with education. And they use them for teaching things like creativity. Another thing that 3D printers are really good for is teaching patience, because they're usually really slow. You know, if you're printing something like a little boat, you know, it's really cool, but something like this could take an hour or more. And the speed record for printing a boat like this was about 2 minutes, and it looked terrible. Because if you speed it up, it gets messy and sloppy, because it actually has to give the filament time to cool down. And the way that it works is it does layer by layer. So they start by slicing the 3D object into layers, and then they draw each layer one at a time and build the whole object. Well, what if there was another way to do it? Well, there is. And I want to show you some work that some Chinese researchers have been working on to make 3D printing faster. Watch this. Okay, can you see this? There's the close-up, and then there's 3 different images of the same thing. Watch carefully or you'll miss it. Did you see that? It's done. Ooh. Now, if you look carefully, you can see the 3D object that they printed coming down in the solution, but it's all the way printed. It's all the way done. And it's a little squid. And so there are a few things we have to realize. First of all, they're not printing layers. They're printing the whole object all at once. And they're using a special rosin that's a liquid that when it gets exposed to an intense enough light that it will harden into a rubbery plastic. And then the trick is getting that to happen all at once. And they have a really special thing. You may have seen that little blink of light. They have a really special periscope that spins, and as it's spinning, it's shooting different projections. It does 1,800 projections as it spins. And those together make the holographic image of the object with the right light intensity to harden the rosin all at once. And it takes 0.6 seconds. So if you blink, you might miss it. It's really, really cool. And other people have tried to do this before, but they were trying to spin the liquid. And the researchers realized the secret to make this stable and faster is to spin the light. And so they have this special periscope. And so let's watch another video of this in action. Watch for the light. There it went. See the periscope spinning? That object's done. They move it over to the side. And then they're doing the next one. Another half a second. And then do another one. See how it's an assembly line? It's like a toy factory, isn't it? It's awesome. Let's do one more. You can see it right there. And so they can just move the fluid. If you look at this diagram, you can kind of see how this works, where they pump the rosin into the chamber where they image it and harden the object, and then they just pump it over into a filter, and the extra rosin can be reused. And they can print a whole bunch of objects really, really quickly with this strategy. Let's look at some of the things that they tried printing out. And in their research, you know, the little soldier figure and the squid and the boat and the jet. And those things with color, they're showing the little holes in the objects. Now, the catch, and there's always a catch, isn't there? The catch is that all of these objects are about 10 millimeters big, little teeny objects. And when you think about how their periscope works, that's kind of a big deal because it's challenging to scale up. And they say that they think they could scale up, but you know, that's going to be another challenge. But the thing that's really amazing still is the precision. They have the accuracy down to 1/5 of a human hair, the detail on these prints. And even though they're printing with that much accuracy, it's still only taking 0.6 seconds. So it's a completely different way to do the printing that opens up a lot of possibilities. In fact, they think that this technology could be used for printing small things. One of the problems with printing is how slow it is, and it makes it so you can't use it for an actual production line. But with this speed, you actually could. And so you could be printing things they say like maybe smartphone camera lenses or micro robots or even optical computing devices where you need to work with these little teeny tiny structures. And so it might be really useful there. And who knows, maybe someday someone like you will figure out how to make it big and fast still. And then I don't know how we're going to teach patience. That's all the tech we have the time for.